ISA ANSI ISA 100.11a 2011 is an international standard at ISA. It was approved in 2011. It was subsequently submitted to IEC for internationalization through the IEC standards process. This year, the IEC 62734 designation, the FDIS received unanimous approval in September. Simultaneously, it's submitted to EN Senelec as the same designation, EN 62734, and that's expected to come out with formal approval this year as well. So both documents for IEC 62734 and EN 62734 should be available soon, I expect by the end of this year. So, the question is, why does ISA submit international standards to IEC for processing through the IEC standardization process? There is even though the ISA standards committees are comprised of more than 600 experts from 200 companies around the world, the IEC is organized by countries, and so IEC approval gains formal acceptance by 52 participating countries. There was 21 voting country committee members on the IEC 62734 standards committee. So we expect expanded adoption rates of IEC 62734, or we call it ISA100 Wireless is our brand. We expect that to accelerate since IEC standards compliance is sometimes a procurement requirement in different jurisdictions. The other piece is that the IEC committee process scrutinizes the jurisdictional regulations for radios, such as ETSI in the European Union or the FCC in the USA. So again, although the ISA standards are international, the IEC standards have better recognition and adoption outside of North America. So I've gotten questions about the ISA 100 Wireless certification, and the answer is that the ISA 100 Wireless Compliance Institute has been reviewing and updating the ISA 100 Wireless certification test requirements to harmonize them to certify to IEC 62734. So we've also been working on test kits to support our certification test requirements, and they'll be available in early 2015, Q1 of 2015. And we will also be in a position to conduct certification testing at that same time, Q1 2015. So there was also questions about compliance with the ETSI 300.328 version 1.81. So that's the European Union requirement, and the updated version of that regulation goes into effect this January. So January 1, 2015, products that are submitted to the marketplace for sales and deployment at user sites, they're going to need to meet requirements for ETSI 300.328. So one of the key things was what's called clear channel assessment. It's also known as listen before talk, and that's a behavior in which wireless devices will listen on the channel to see if anybody else is broadcasting on that channel, and if not, they will the device will broadcast. And the objective of that is to have to enable compatibility and playing nice of wireless devices that are sharing the 2.4 gigahertz radio spectrum. So the listen before talk characteristic is defined in the base IEEE 802.15.4 radio, which is the physical layer used in ISA100 Wireless. There are other protocols that use 802.15.4 like Zigbee and wireless Hart, and there's some others. It's not always implemented in other protocols, but it's definitely implemented in ISA100 as a mandatory requirement. So ISA100 Wireless, when it went through the committee process, IEC 62734, included additional features and functions to provide suppliers flexible approaches to comply with the ETSI requirement. The base standard, as it came from the ISA 100.11a, included country codes, so you knew what country the device was in, and the ability to attenuate output power levels. Generally speaking, if you're broadcasting, your device is broadcasting below 10 milliwatts, there's nothing complicated. It doesn't need to do listen before talk, but when it exceeds 10 milliwatts of output power, then there are more complex algorithms that you go through for how the listen before talk or clear channel assessment behaviors are executed. So the 62734 standard includes an annex, Annex 5, an informative attachment that describes multiple scenarios and approaches to ensure ETSI compliance. So, but today, if you're an end user in the European Union with ISA 100 wireless products installed, or they're in your procurement plan, ISA 100 wireless complies. If you're a supplier evaluating wireless technologies for your product line, ISA 100 wireless meets the pending EU requirement. So products have been shipping ISA 100.11a since 2010 under the ISA 100 wireless brand. There's installations around the globe, well over 150,000 devices connected in 2012, and consistent growth over the past couple of years and projected for the next 5 years. There's more than 1 billion hours of operational experience with ISA 100 wireless devices around the world. I included an installation map. It shows by color code the various installations around the globe. The color codes indicate what industry vertical are addressed by the wireless devices. So we have chemicals, life sciences, mining, oil and gas, refining, and pulp and paper, and there are others. So there are there's a large number of ISA 100 wireless devices that have been developed. We have a website where we list the wireless devices that we're aware of and the wireless device, ISA 100 wireless devices that are certified. So the URL at the bottom of this slide would show you ISA 100 wireless devices, both registered and just others. We've brought on a lot of companies in the last couple of years, and they're developing products. So here's a sample list of the products that are in the pipeline. I won't go down all of them, but it's a pretty goodly number of gas detection and steam trap monitoring. The usual cadre of pressure and temperature sensors is fairly well represented, but I just thought I'd note a few of these others. Okay. So just a quick note about the ISA 100 Wireless Compliance Institute. Again, we're a consortium like Fieldbus, Hart, OPC, and the others. We are member-led. We have a governing board of members. Current chairman is Ray Rogalski from Honeywell. The vice chair is Penny Chen from Yokogawa. Then they set the strategy and direction, and the ISA100 Wireless staff support team does the day-to-day operations. I'm the managing director, and I run that. So we do the marketing, outreach, manage the certification programs, etc. Just a few of the member companies, major oil companies: Chevron, BP, Exxon, Aramco Services, a few of the Tier 1 suppliers like Honeywell, Yokogawa, GE, and other companies that you might recognize. So membership, user and supplier support is growing. We've got a trend line that's heading up in a healthy way, and we expect to see that grow the same or better in the upcoming years. We don't operate in a vacuum, so we have collaborations with other standards groups like FDT and Fieldbus. We expect that to continue and grow as well. A necessity of our health is having a healthy technical ecosystem. So there are some product integrators. There's one in Romania, CDS. They're a NIVIS channel sales partner that supports the EMEA region. And Centero is based in the United States. In Atlanta, they're also a product integrator, and they distribute NIVIS products such as communication boards and stacks. We've also established an agreement with Centero to assemble and distribute the ISA100 Wireless test kits. Yokogawa is now offering components to any supplier, like their universal antenna module. There's a few other products that they'll sell to anybody, not just partners specifically. And they're establishing distributor arrangements so that companies can buy these components and have the marketplace invisibility to Yokogawa. There's other companies. Gilead, Nexcom is a healthy company that does ISA100 wireless infrastructure products. They also do integration services. So I thought I'd just take a couple minutes here and highlight a few applications that accentuate the unique capabilities of ISA100 Wireless. So ISA100 Wireless is pretty well represented by the standard process industry. Sensor devices such as pressure and temperature sensors using the ISA100 protocol natively, if you will. But there are other capabilities that are in ISA100 Wireless that fall under the heading of no regretted investments and also unique enabling technologies. So by no regretted investments, we mean that if an end user already has systems installed at their site that are wired, such as a system based on Profibus or Fieldbus Foundation or Hart, and they want to extend that system, and wireless would be the best way to do it, they can do that and send those signals wirelessly through the ISA100 network infrastructure without modifications to their native protocols and their installed application. So that supports the concept of no regretted investments. On the flip side, for suppliers who have products that are developed with proprietary protocols, they can get their products to market for wireless capabilities rapidly due to either tunneling or object capabilities for sending data through ISA100 network infrastructure. So there will be a couple examples of that here. So gas secure. This is unique. It's a infrared gas detector. It's high reliability, and it's been certified to SIL 2. So it's one of the first products that I'm aware of, if not the first, that's a wireless product certified to SIL 2. So what they were able to do was develop this product, put a Profi-safe layer in the product, and use tunneling and some other features such as contracts, which is quality of service, to send signals through the ISA100 network and gain their SIL 2 rating. So they partnered with Statoil in the North Sea, was their field trials, 20 detectors, and it was very successful. This is an extremely successful product, and it's taken off pretty quickly. There's hundreds of devices being installed at this point. So again, you know, it's a wireless Profi-safe being tunneled through ISA100 Wireless and working its way back through Ethernet backbone. So what they liked about it was it had native IPv6 addressing. You could do contracts, which is quality of service, which means that there's guaranteed delivery of packets, and that was important for safety. And this is it's bidirectional. ISA100 Wireless has support for fragmented packets, slow hopping, variable message length slots, and can support pretty much any network topology you want. So these things all combine to enable Gas Secure to build a product that met the Profi-safe requirements. So there's a company, Ultra 3 ETI. They come from the United States Department of Defense contracting world. So they build a lot of products for the DOD. So they have a seemingly generic ISA100 wireless gateway and sensor nodes. And for the DOD, they have what a set of security requirements called FIPS 140-2 for cybersecurity certification. The NIST standard, and DOD uses it. And so what they did was they used a certified ISA100 wireless radio module, and they were able to have their devices certified to the DOD FIPS 140-2 requirements. And again, the flexibility of the ISA100 stack allowed them to do an update and meet these requirements. General Electric, they have condition monitoring applications. So they have something called the Essential Insight Mesh. So the little blue nodes are mesh networking nodes. It has the power source inside of it. You can use energy harvesters to power it. You can use line power. You can use batteries. You can drop up to 4 devices off of each of these nodes. In this picture, you see it communicating back to Yokogawa Gateway. What's interesting about this is that GE built this. They had a proprietary protocol for pushing waveforms back to an analytics workstation for analyzing the waveform data. And so under this configuration, you can see you can have real-time data going back to a control system for process monitoring, if that's a requirement, and then large data sets pushing their way through the ISA100 mesh network to be aggregated in a System 1 for data analytics. So this is done real time. It's not like you start the process and do it overnight. It can take a little while for it to get through, but you're going to get it, in a matter of hours, not overnight or days. And there's not a backhaul or out-of-band requirement to get the data back to the analytics station. So again, it's a proprietary protocol. They had financial savings in bringing their product to market because they didn't have to change it. they were able to use objects to push their data in their proprietary format through the ISA100 network and be consumed by their Series 1, or System 1, I should say, analytics application. So these are just options for mounting, that sort of thing. This is one of the more interesting applications. It's disposable sensors for satellite, and so it kind of fills two of the key attributes of ISA100, also known as lick and stick. So basically what's going on is a large number of sensors are being attached to a satellite for conducting tests during assembly, integration, and test of the satellite. We're going to be hosting a webinar on it, and the manager from CDS will provide details on it, but I'm going to find this one to be extremely interesting personally. So they have a wireless temperature and vibration sensor system developed for the European Space Agency. The system is mounted onto satellites. They collect the information. In this case, there are hundreds of sensors that are typically wired today, and by using ISA100 Wireless, they can take these hundreds of sensors and wirelessly communicate. And so there's two things that I find interesting. One is there's hundreds of sensors. It's a large network. And the other piece is that when all the testing is done, they short out the sensors and they basically don't use them anymore and dispose of them. So it's what I would call a lick and stick application, where you take a bunch of sensors, just use them temporarily, throw them away, just treat them as disposable. So this will be during the week of November 10th, and we'll send out an email invite on this. You should find this pretty interesting. So more straightforward, again, Honeywell has a Hart adapter. Yokogawa's got a Hart adapter as well. And so again, the Hart protocol is, what I would call a legacy protocol. And with the Hart adapters, the ISA100 wireless network allows Hart commands and data to be transmitted through the network. You can do it one of two ways. You can do tunneling and have a Hart host system at the top and just run a regular command-based Hart application, or this adapter will run in a different mode in which it converts the Hart commands to what I would call native ISA100 wireless, and it can be consumed by a different type of a host like ISA100 host. Honeywell acquired a company called NRAF. They make FlexLine level sensor. It's a radar sensor. This product also uses fast Fourier transformations or waveform data sets, and it's a proprietary protocol. So Honeywell was able to bring this product online rapidly, bring it into the wireless world. They used just straight tunneling. So the proprietary protocol for this is just sent through the ISA100 wireless network with tunneling. It keeps its protocol. The host application consumes the data in its host protocol format, but with the tunneling, there was no need for a separate type of a network, and the product was able to be brought to market rapidly. It's validated for SIL 2 and SIL 3 applications. So, again, another example of a foreign protocol being transmitted in the ISA100 network. It goes back to the key drivers of the popularity for companies that are converting product from wired to wireless. The contracts gives you quality of service and guaranteed packet delivery, so that's important for high availability applications and high reliability applications like SIL safety integrity SIS systems. And then there's just the flexibility, slow hopping and variable message lengths. The long message lengths allow large amounts of data to be pushed through the ISA100 network. Object-oriented design, same thing. And the meshing scheme is flexible. So if you want to have full routing and full meshing, you can do that. Just depends on what you've discussed with your supplier. They're not going to show up and give you a bunch of devices that you're going to have to then configure. They'll show up with devices that are ready to go and meet your meshing scheme. The native IPv6 devices are addressable using IPv6 right to the device level and tunneling. So you could have several different applications running in one infrastructure, and they could have different timings. It's configurable. So again, no regretted investments. Here's just the standard picture from the original ISA100 committee process days, showing a mesh network with Hart commands, FF commands, and objects in the network, device net. They can all work in the same network, ISA100 Wireless. So, one of the questions I get is, why does IPv6 and ISA100 Wireless matter? Well, IPv6 is important to have full addressability to the device and with IP, Internet Protocol, and it's the only protocol standard to incorporate IPv6 directly as part of its network and transport layer. You can support multiple subnets, enabling sensors to be grouped like a VLAN. And IPv6 is really, it's just a networking standard of the future. Everything's going to be going to IPv6 eventually. And engineers and the kids coming out of college, they understand IPv6, the IP addressing. So you can manage these networks using tools derived from traditional IT network management tools and systems. So it'll be a common architecture and create a common understanding for future generations. So it does a little bit more than just to increase the IP addresses. We all know they've kind of run out. So it has better security. It has support for new services. It eliminates the network address translation and gives true end-to-end connectivity at the IP layer. The algorithms for routing are more efficient. They reduce table sizes, etc. More efficient packet processing, and a few other items. So that's pretty much it. That's the update on ISA100 Wireless, and I'll be happy to take some questions at this point and see where we go. So we got some questions, Mike?
I've got one question.
Okay.
Will the Field Bus Hart work and the impact of collaboration with Field Bus Foundation?
Will the field bus Hart merger have impacts on collaboration with field bus? I can't predict that. I hope not. You know, we have a good relationship with Field Bus Foundation now, and you know, we've worked with the Hart Foundation at events such as the Field Communication Lounge in Germany at Hanover Messe. So we'll see. We hope not.
The question is, can you compare and contrast ISA100 to IEEE 802.15.4G?
.4G, 15.4G. I can't. That's beyond my pay scale. So I don't know how to. I can't answer that for you. I'm sorry. I'm not that technical.
Another question is: are there any significant technical differences between ISA 100.11a and IEC 62734?
No, there isn't. The fundamental underpinnings of 62734 are pretty much the same as ISA 100.11a 2011. ISA 100.11a was originally published in 2009. There were some updates, and most of those were addressing security in the 2011 version that was published. And the 2011 version is what was submitted to IEC for the IEC approval. And those are fairly similar. There are some minor additions to 62734 that expand the capabilities for ETSI compliance, but the basic requirements for ETSI compliance, like listen before talk and country codes, they're all there. So not huge differences. Most of the differences are actually in the informative sections of 62734 that helps you to understand how to use it.
Okay, another question. The number of wireless instruments that are connected to a gateway is limited to around 10 if 1 second scan time is desired. This is a limiting factor in big projects. The cost of gateways is considerably high.
I don't think that's true for scan times, for 1 second scan times. I'll have to go back, but Yokogawa did some studies. There's direct math related to it, but I believe you can have 200 devices connected to a single gateway with, I think it's 20 access points, and up to 500 devices connected to a single gateway with more access points, and the scan time's at 5 seconds. But there is a mathematical limit just based on time slotting and scan times. That's true. But can you repeat the question one more time so I make sure I'm getting this right?
The question is, the number of wireless instruments that are connected to a gateway is limited to around 10 if a 1 second scan time is desired. And he's saying that this is a limiting factor in big projects. The cost of gateways is high. So I guess the question is...
No, it's not. 10 is not it.
10 is...
No, that's 10 is like way low. If that person can send me an email, I will send him studies that were done by Yokogawa on that topic.
Okay.
Numbers of gateways and access points. Yes.
Okay. Next question. Is there a reference guide for implementation of an ISA100 wireless network available?
We are working on a generic implementation guide for ISA100 Wireless. The companies that are doing larger deployments are the two larger suppliers in the Institute. That's Honeywell and Yokogawa. And I know they have deployment guides if you're doing larger networks. But if you're doing networks of like 40 up to 50 devices or so, it's really not going to be that complicated.
You mentioned with the Hart adapter, max length being about 350 meters, but if relay process area, we won't have clear areas. There will be equipment reactors, so signals won't have a clear route. So please distinguish.
The Hart adapter.
So he's saying that you mentioned the Hart adapter has a range of 350 meters, the max length range, but in congested areas, how is that affected?
Okay, so I think the first thing is you can subtract Hart adapter out of there. It's really the radio transmission of the ISA100 node, whether it's a Hart adapter or individual device. But the field trials have shown in congested environments 300 meters for congested environment transmission. Line of sight 600 meters with almost no packet loss, and then you can use attenuators or boosters and get longer distances, a mile or 2 miles. But yeah, 300 meters congested, 600 meter line of sight is the rule of thumb.
Okay. The next question, is there any news in regard to the ISA100.12 and the merging of the ISA100 protocol with wireless Hart?
So ISA100.12 was a working group within the ISA100 Standards Committee process. That was disbanded a year or two ago because it was not making any progress and there was no work being done. There was a suggestion by the users a couple of years ago for the suppliers to sort out convergence, and that was taken outside the committee process through a process that is known as the Heathrow Group, where supplier members sign an agreement to work on convergence between wireless Hart and ISA100. But ISA100.12, the convergence working group, that's been disbanded for more than a year now.
The next question, how will the IEC approval help with the ISA84 draft for wireless devices used in IPL applications?
Can you ask that question again, please?
Sure. How will the recent IEC approval, IEC 62734 approval,
right,
how will that help with the ISA84 draft for wireless devices used in IPL applications?
I can't answer that right away. So ISA84 is, I believe that's the U.S. version of IEC 61805 and 61811, the safety standards for safety instrumented systems. I don't know enough about what's going on there, so I apologize. I can ask somebody from that committee, though.
Okay, the next question. If 40 to 50 sensors is not complicated, at what number of sensors will it become complicated?
I would, my recommendation is to get with the suppliers who are doing the deployments to tell you when they start hitting the wall. I'm not doing deployments myself. I'm just working anecdotally off of what I hear from my discussions, but I don't know.
Okay. The next question: do you have any success in getting more suppliers to develop ISA100 options, specifically Enders Hauser, Samson Controls?
So, there are. We're talking to suppliers every week, and so more are coming on. Some are developing product that aren't members. They're doing it as an R&D project, and we're finding a lot of that going on. And then we're kind of notified at the last minute. But I would like to talk about who's developing product like Anderson Hauser and Samsung, that sort of thing. But I don't like to do that. I don't do it because that's their those are their proprietary marketing information. So until they make some kind of an announcement, we won't say anything either. I'm sorry. I wish I could say more.
Okay.
But
okay. The next question. So he says wireless Hart is redundant, so the chances of dropping in signal are low. How does ISA100 Wireless ensure reliability?
So actually, I guess you got to be careful about the terminology. So like with wireless Hart, you can send information through alternate paths. It doesn't send the same signal twice through two different paths at the same time. If it's going through one path and it's not making it, it'll switch. So it's really alternate, not redundant. ISA100 uses duocast, in which it's built into the protocol where device will send information through two separate paths to arrive at two separate gateways for redundancy. The first one that arrives wins, and that increases the probability that the information or the signals are going to get back to a host system or where they need to go more reliably. It really enhances the predictability, and that enhances the ability to do control. Enhances the ability to do SILT type things, safety type things. But I think that answers that question.
Okay. The next question. Are there any issues with ISA100 Wireless in congested areas such as echo or ghost signals?
I can't answer that. I can find the answer to that. That's more specific than the feedback I've asked for or received. But I know that in real applications and in test field trials, that signals are getting through with very high levels of reliability. So, with very few packets dropped, that kind of thing. So, I don't know if echoes or ghosts have other issues, but in the end, the signals are getting through and the systems are operating reliably.
Okay, the next question. Do you give presentations to local ISA chapters? And if so, how can we contact to arrange a presentation?
Yeah, so absolutely. Just send me an email, and I can arrange that. You can send the email to myself or to Mike Brosda. But yeah, we'll work with the local chapters, and we can send somebody from here. I could come down personally, or we might. It might be better to have one of the local representatives from one of our member companies do a presentation, and sometimes that's better because they can bring product there that you can look at and touch and ask more specific questions.
The next question, do you have live demo units to demonstrate ISA100 systems at trade shows or seminars?
Yeah, we do live demos. We don't keep live demos here at WCI. We have product that we show for static display, but our typical arrangement is to make plans with local companies where possible to do the live demos. We will be at ACMA this year in June in Germany, so we're going to have a pretty big display of live demos there.
Okay. The next question, is there any news of Emerson following ISA100?
Emerson has not contacted me about building ISA100 products yet.
The next question, how does ISA100 Wireless work with IEEE 802.11?
Okay, so that's Wi-Fi. So they're in the same 2.4 gigahertz radio band, and so there's a couple things. A lot of companies, all right, so number one is ISA100 has the clear channel assessment, or listen before talk, if you will. So it plays nicely with other devices that are broadcasting in the 2.4 gigahertz band, like 802.11. Some deployments are bridging ISA100 to 802.11 to bring data or signals back as kind of a backhaul arrangement. And there's a variety of different configurations and topologies that I see, but I do see them used together a lot, or hear about it.
The next question, are there any plans for ISA100 and wireless Hart protocols to talk to each other and join either network?
We don't have plans for ISA100 and wireless Hart to talk to each other. The wireless Hart systems right now operate differently. They use fixed time slots of 10 milliseconds. So, and it's command-based, host to device. So there's a constant conversation going back and forth. So the basic operational paradigm is different. ISA100 can be a little more independent as to how they operate. They can use objects and that sort of thing. So right now they're not talking to each other, if you will. They can coexist.
The next question asks about coexistence. Is there any issues in terms of coexistence with other networks such as Wi-Fi, wireless Hart, Zigbee, etc.? Right.
So that was the whole point of the CCA, or clear channel assessment, using that capability that's in the 802.15.4. So we listen before talk, so we're not stepping all over other devices that are broadcasting and receiving. And so yeah, that was one of the key characteristics that was on the end user's list of requirements. And so we do that. We coexist well.
The next question, can you give us a brief update on development of CNM, Common Network Management?
I can't. I'm sorry, I don't work on the Common Network Management. I know there is a working group that's looking at that. I know that it's kind of a boiling the ocean task. It's pretty big, and but I don't know where the progress is. Herman Story, who's the co-chair of the ISA100 committee, he could help out with an answer on that. But I haven't heard any huge progress in that. Again, it's a pretty big undertaking. Okay. All right. There's no more questions. This webinar's recorded. The slides and the recording will be available on the ISA100 WCI website under the is it the Learning Center?
Yes.
So you'll find it there. Hopefully we'll have this by the end of today, if not tomorrow. Again, thank you for your time, and have a good day.
There is one last.
One more question?
Okay. Yes. One more question. How is the ISA100 end-user approval in South America? Do you know if there are any large applications in Brazil? And does wireless Hart standard already have IEC approval?
So the wireless Hart standard is 62591. That was approved about 3 years ago. I would have to talk to our members to see what the uptake of ISA100 looks like in South America. I don't have a whole lot of visibility into that personally. I have better visibility in Europe and Japan and Asia. But if you send me an email, I'll look that up for you. I'll see if I can do some digging. Okay. Again, thanks. I'll give you 3 minutes back, and have a good afternoon or good evening, whatever it is in your time frame.